Spent 12 years at NASA as an astronaut. Got to fly the shuttle a couple times. Got to fly Russian Soyuz right after we lost Columbia. Got sent to the space station for 6 months, just a few weeks after we lost Columbia. As part of the first two-man crew, as we grounded the shuttles, we decided that it was possible to send 2 people to the space station. And so I was dispatched off with 48 hours notice to go to Russia to learn how to fly a Russian Soyuz. Did the training in 9 weeks, basically about 20 hours of training per day, 7 days a week for 9 weeks. Most tiring thing I've ever done, and then spent 6 months with just one Russian guy on board the space station. Left NASA in 2007, went to Google for a number of years, ran advanced projects there. We are doing things like the imaging systems for Google Earth and Maps, Google Street View, Google Books, book scanning stations, energy projects, Google Power Meter, and a bunch of crazy projects which never saw the light of day. Left Google about a year and a half ago, and been running the B612 Foundation since then. And anybody here ever heard of it? Yay! Okay. We actually started about 10 years ago. It was a group of astronauts and scientists who were looking at the problem of how you would deflect asteroids from hitting the Earth, because it does happen. And we were originally working on the problem of simply deflection, because all along we had assumed that the first step, which is to find the asteroids that are going to hit the Earth, was going to be done. We had assumed that the governments of the world would do this. NASA was aware of it. They had actually discussed doing a large-scale survey, finding all the asteroids that could hit the Earth, and that the problem would be how would you deflect them. So we spent 10 years looking at the problem of how you would deflect an asteroid, and which turns out to be, once we and other folks began to understand the nuances surrounding it, actually turns out to be not that difficult. If you have many decades of notice, like sort of picture an asteroid circling the sun, and the Earth also circling the sun, and the orbits intersect at some point. But if you find that there's going to be a collision, but sort of 50 orbits ahead of time, then you just need to change the orbit a little tiny bit. And what you actually do is change the timing so that when the Earth and the asteroid, they're still going to have a crossing, but now the asteroid gets to the intersection point a couple minutes early or a couple minutes late, because the Earth is a moving target. It's moving approximately 65,000 miles an hour around the sun. It doesn't take long for the Earth to travel its distance of, it's only 8,000 miles across, right? So there's where, if you delay or speed up an asteroid such that, 50 orbits later it gets to the intersection point a couple minutes early or late, there's no collision. And we designed a number of ways to do that. This is something called a gravity tractor. There's an asteroid there, and small spacecraft in front. All you have to do is have the rockets of your spacecraft not point directly at the asteroid, but sort of canted outwards, so the exhaust doesn't hit the asteroid. And if you just hover near it, there's a force between the two. If you take sort of a typical sort of candlestick park-sized asteroid, and a spacecraft is maybe half the size of this table, which is not that large for a spacecraft. The gravitational pull between them is maybe 1/10 of a Newton. Not very much, maybe this much weight. But if you integrate this much force over many, many months, that's enough to change the velocity of even a very, very large rock like that by 10 to the minus 3 or so, 10 to the minus 4 meters per second, which if you integrate out by 50 years is enough to make it miss the Earth. Turns out to be actually relatively simple. But again, you can do other things too. You can run a spacecraft simply into it. Not so controllable, but you do give it some momentum, right? And also works well. So there's a number of things you can do, as long as you have lots of notice. If you have 1 or 2 years notice, it's nearly impossible. It goes from easy to impossible, and it's a pretty sharp transition in about a decade or so, to the point where even nuclear weapons are not going to do the trick down even close. So the real key is, get decades of notice. But as you know, NASA's pretty good at doing tracking and targeting of things, right? I mean, look, we landed this Mars landing the other day, and it's something like only 200 meters off its expected landing spot. So You know, we're sending something to Pluto, right? It's taking over a decade to get there, and it's going to pass by Pluto at a known distance, and they'll be within a few kilometers of where they you know, hope to hit it from. So we understand orbital mechanics, we understand how to track things well off into the future. The key is actually doing it. So we had this little nonprofit foundation, which was basically 4 guys on a website, and we're a nonprofit foundation simply so we could have some sort of affiliation that we could publish papers on. We basically raised no money, we spent no money, we would just, you know, we would occasionally go to conferences, that sort of stuff. And about a year ago, we realized, you know what, nobody's going to do the survey. As ridiculously obvious as it is that you should be looking for asteroids that might hit the Earth, nobody was going to do it. The government is not going to do it because the government doesn't do anything very well where the benefits are decades off in the future and they're probabilistic. You know, the amount of money it takes to do this might be hundreds of millions of dollars, which over a decade's time, which by government standards is, you know, what they spend on coffee at the Department of Defense, but you know, it's just not going to get done. So I was giving a talk at Google about a year ago, and some guy in the audience just said, well, why don't you just go and do it? And I thought to myself, I'm like, well, you know, how are we going to raise the money? He goes, why don't you you're already a non-profit. He goes, you know, we're raising money to build a new wing of the art museum in San Francisco. You know, the SF MoMA. Anybody here ever been to it? You know, they're building a new wing on it right now. You know how much the new wing costs? Anybody here even donating to it?
200 million.
400 million. Okay, and they'll raise that money over 5-6 years. They'll be successful just like every other municipal civic project, and nobody bats an eye about it, right? Anybody here been to the California Academy of Sciences building? You know, the Science Museum? It's an awesome building, right? They raised $505 million for that, just from people in San Francisco. So this guy's points out, he goes, look, any given time in the United States, there's 50 to 100 projects of a few $100 million. They're all successful, and they're all local. Because if you guys are global, like if the people of San Francisco can build the wing of an art museum, can you go worldwide and build something that could save the future of humanity? And we thought, hey, let's look into that. So we have. What we did since then is we've completely switched our focus of interest from, now that we and others understand that the deflection of asteroids is quite doable, we switched to the problem of how you would track all the asteroids in the solar system. So a little movie sort of shows what we're up to here. This is from our a presentation we made at the California Academy of Sciences just about a month and a half ago when we went public with our plans. We're called the B612 Foundation. B612 is, if anybody here read The Little Prince? That book. The Little Prince lived on an asteroid called B612. So what we, you know, that's what it's all about. It's about protecting the Earth. In fact, the incidence of asteroid impacts, I should pause it here real quick for a second, is a lot more than people think. The last sort of major asteroid impact was about 100 years ago, 104 years ago to be precise, 1908 in Tunguska, Siberia. It was not that big of an asteroid, maybe 40 meters across. So, you know, probably half the size of this building. And the explosive area of that, or the explosive energy of that was about 1,000 times the Hiroshima bomb. And it took out an area of about the size of the San Francisco Bay Area. So if you drew a round circle of about from, say, Marin County, you know, say Sausalito down to San Jose, and draw a big circle, that's about the area that was completely obliterated. And happens just about every 100 years or so on Earth. 100, 200 years or so. It's a little bit that's about the average rate of those impacts. And that's, you know, most of the Earth is unpopulated, but less and less of it is. So that's at the very lowest end of the scale, 40 meters. When you get to something about 100 meters across, those are a little less frequent. Those are about 1% chance per century of hitting the Earth, so about every 10,000 years. That, however, is about 100 megatons. For scale, if you took all the bombs used in World War II, added them all up, including the atomic weapons, multiplied by 5, that's about 100 megatons. So, you know, within your lifetime, there's about a 1% chance of essentially that happening. World War III, the equivalent of World War III. And that's not that small. In fact, it's almost exactly the same as your odds of dying. In any given day, the odds of the Earth being hit by a 100 megaton impact are about the same as your odds of being killed in a car accident. So in every single day. So you know, what I always ask people is, do you wear a seatbelt, or do you have an airbag in your car? And I go, well, why? Your odds of dying in a car accident are not that big. Why don't you put your kid on the roof? That's, you know. Why do we take those simple precautions, right? Because it's something very precious to you, right? Your lives or your kids' lives or so on. But in some sense, the Earth has this, has the same risk on any given day of 100 megaton impact of you dying. And, but the difference there is that everyone's riding the same car, right? I mean, why aren't we taking even a tiny amount of our resources, tiny, absolutely tiny, you know, 1/3, 1/2 the price of a major, of a freeway construction project or of a freeway interchange project to do something about this? Because if you don't know something's coming, by definition, there's nothing you can do. In fact, the expected warning time right now of a large impact is exactly 0. And we'll know of the next large asteroid impact when it happens, simply because we're not scanning the skies looking for these things. We do a pretty meager job of it. We do it using ground-based telescopes now, looking in the direction away from the sun when the moon is not full, from a handful of telescopes around the Earth right now. And thus far, over the last 20 years, we've managed to discover and track about 1% of those asteroids that are actually orbiting the sun. So at this rate, we will essentially never finish, because the asteroids change their orbits on timescales of about 100 years. Essentially, it's just not going to get there. And you know, so our question is, well, why not? If you could build half of a freeway overpass, why not just protect the Earth by finding what's out there? The odds are small, yes, but it would truly be stupid if we as a civilization ceased to exist, or had hundreds of millions of people die, simply because we didn't choose to do something about it. So you know, I look at us as being one of the sort of more ambitious groups in Silicon Valley in some sense. So what we've done since last year is we put together a team. We've I'll explain it. Let me show you a little bit what sort of the geometry, so you understand what's going on out there. Again, this is the Earth, stepping back, looking at the big picture. By the way, this looks a lot better on the big planetarium dome. This was originally done on the planetarium dome up at the California Academy. So there's the orbit of the Earth right here. The green line. The Sun, Mercury, Venus, Earth, Mars, Jupiter. And that's the asteroid belt. These are the positions and locations of every single known asteroid, and these are all accurate. So the asteroid belt, which is this out here, is not what we're talking about. There are 10,000 of these, what are called the near-Earth asteroids. These ones right here flying past the Earth, which is really sort of flying around in a shooting gallery, as you can see. That's every single known near-Earth asteroid. Near-Earth asteroid means ones that actually cross Earth's orbit. But remember that there's about 1 million of these, so that's 1% of what's really out there. And what we want to do is map all the rest of them. So let me show you what it really looks like when there's 1 million of these things. Now, hopefully the resolution of the screen will show it. What we've done is we've actually taken the known distribution, multiplied it by 100. That's the actual situation out there. And we want to track every single one of these things accurate enough so that we know their position within a few tens of kilometers out to the next century. It's quite a challenge, and I'll show you how you can do that. So that is really what it looks like in our solar system. And
are they coplanar, or?
The width of the distribution is about 20 degrees or so. So it's pancake-ish looking. So let's. Go ahead.
Sorry. When you say
let me pause it here.
we know about 1% of them, and then you multiply to get how many are there really there.
Mm-hmm.
How big does an object have to be to count as an asteroid?
I've counted ones larger than Tunguska, than the one that hit Tunguska. Things smaller than that, mostly they begin to just dissipate in the very, very upper
Right,
reaches
so
of the
they're all
atmosphere. Yeah. So these are the ones that would have some serious ground damage, all right? There are some smaller ones that if they're made of the right material can actually cause a lot of damage, like Meteor Crater. It was only about 20 meters across, but it was made of iron, so it came all the way down, hit smack into the ground, made that, you know, if there was anybody living around there, well, there was a lot of animals living around, that was only 50,000 years ago. You know, anything close, you know, 30, 40, 50, 60 miles probably was killed instantly.
Would it be better if it hit the land or the sea?
Depends on the size. If you are larger than about 100 meters, or then it's almost certainly better to hit the land, because then if you land in the ocean, you're looking at a tsunami. And it's a pretty epic tsunami. So sort of this 100 meters that we talked about, the 100 megatons, put 100 megatons in the, you know, you land it on the water, which at that speed is concrete, right? You just make a crater in the water. And a way to think about the size of the wave is that the crater is going to be about 20 times or so the diameter, so maybe 2 kilometers across, and about 2 to 3 times the diameter of the impactor in depth. So maybe 300 meters deep. So you create a crater in the water. Well, what happens? It fills back in. And how big is the central peak? How big is the wave coming out of it? It's about twice the height of the crater, right? So 500-600 meter wave. Okay, very, very bad. And so that's, the actual danger then is much worse, because 70% of the Earth is ocean, and if you get 100 meters or larger, actually you're looking at large tsunamis. And given that you know, half of the Earth's population lives within a few miles of the oceans, it's potentially pretty bad, right? So, let's move on. Let me show you what we're going to do. We're going to launch a space telescope, and we're going to launch it off of the Earth. And we're going to fly inwards in the solar system. We're going to fly past the planet Venus, which is coming up. This is our space telescope. It's called Sentinel. It's going to swing by Venus. We're going to use the gravity of Venus to pull ourselves into solar orbit. The space telescope is an infrared space telescope. That's it. It's based upon the design of the Kepler Space Telescope and the Spitzer Infrared Space Telescope. It's kind of a mixture of the two. And here we are. I'll show you why we're going to this orbit. This is the Earth. There's the telescope. This is Venus. And you'll see that it's sometimes, the Earth's orbit is out here. You'll see that it's sometimes on the same side of the sun, sometimes it's on the opposite side of the sun as the Earth. And that means that it will be, what it's trying to do is scan the areas looking outwards, always looking away from the sun. And that means that you can scan to search out all those asteroids. You want to be on the opposite side of the sun as the Earth at times. And you want to be in infrared for the following reasons. Because in infrared, the asteroids stand out. This is what an infrared sky looks like. That is an actual infrared image of the sky in the background, taken by the WISE satellite. And in infrared, these asteroids, they glow. And so we're essentially measuring their velocities and positions by picking them out by their glow. So this is going to be a 4 to 10.4 micron detector, broadband infrared space telescope. And it'll beam its information back to Earth. For scale, this thing is going to be between 30 and 170 million miles from Earth when it's in the final orbit. It's about a factor of 500,000 times further than the Hubble Space Telescope is from Earth. So we have quite a data rate challenge. Clearly doable though, you know, this is roughly the same distance as the Mars landing was the other day, so you can do these sorts of things. So here it is in its final orbit. I'll show you how it scans the solar system. So there it is, going around the sun. Here's the Earth, showing all the asteroids again, and that's its field of view. What it will do is, because it's always looking away from the sun, so this sort of pi wedge is the area you can see. This is the Earth. So sometimes it'll scan the Earth's area, sometimes it's scanning the other side. And as this thing goes around the sun, it takes 8 months for it to go around the sun, it will basically track all of those asteroids. And this was a concept first come up with about 10 years ago, and since the National Academy of Sciences actually decided to do a complete report on how you would do such a, how you would map all these asteroids. And they essentially endorsed this concept, saying this is the most effective way to do it. Nobody really had any, there's no funding for such things. What we did is we approached the guy who actually came up with the concept, the guy named Harold Reitzema, who was with a company called Ball Aerospace. They built the Spitzer Space Telescope, they built the Kepler Space Telescope. You know, all the discoveries of planets, those were made by Kepler. They're a sort of a medium-sized spacecraft corporation, but they're far and away the most nimble of the large space companies. And approached Harold, who had since retired from Ball Aerospace, and said, hey, if you could find a way to build this thing, if we could find a way to build this thing privately, would you be interested in running it? And how would you run it? And he said, well, yeah, I'd love to do that. You'd have to do this under commercial terms, but it could be done under commercial terms. Rather than a government contract, you could actually pay a firm fixed price contract for such a thing, because I think this is within the capability of something we can build. So, you can probably bring the lights back up. Want to hit the lights? Yeah. So I went to Harold and said, let's see if we can do this. So next person I went to is a guy named Scott Hubbard. He's currently a professor at Stanford. He used to run NASA Ames, and for a number of years he was the Mars czar. Do you remember the set of embarrassing failures they had back in the late 90s with Mars missions? Well, he was the guy that was sent in to fix it. He ran the NASA Mars program, so Sojourner, Spirit, Opportunity, and the lander from the other night. He ran all those programs, fixed the NASA Mars program, sort of widely acknowledged as the best spacecraft leader in the world. Recently retired from NASA, become a Stanford professor, had lunch with him and said, hey, in a perfect world, if you could run a large space telescope program, how would you do it? He said, well, I'd run it under commercial terms now. We could do things like with commercial rockets and so on. I go, well, how'd you like to do that? And he said, well, sign me up, essentially. So we brought him aboard. And then I said, well, Scott, let's talk about it. Who is the very, very best technical spacecraft guy in the world? And he goes, well, that's a guy named Tom Gavin, who ran JPL's technical division for 25 years. He was the leader of the Cassini mission to Saturn, the Galileo mission to Jupiter, and then he ran a couple of the Mars rovers programs as from the technical end. What they do is they always split off a separate technical group whose job is not managing the program, but to look for errors in the main program. A completely independent team, and he's run those teams out of JPL for 25 years, just recently retired. So well, let's go talk to him. So we talked to him, posed the same question. He goes, oh, I'd love to do that. He goes, I think our way of doing business right now at NASA is not viable long term. He goes, sign me up. So he's our now technical program lead. And we then went to NASA and said, all right, we're going to build this and finance this ourselves. We're not asking for money, but what we would like is to cooperate with you guys, because you guys own facilities, spacecraft tracking facilities, large antennas called the Deep Space Network. It's the antennas around the world that are used to communicate with everything from satellite, spacecraft on the way to Pluto, to the ones going to Mercury, to the ones going to Mars. And we didn't want to rebuild large antennas on the ground. We said, well, if we make the data free and open, put it out live, will you do the tracking and the telemetry for us? Allow us to send our commands through your network. They said, yeah, we love that. That's the data they want. They can get it for free. So we signed an agreement with NASA. They even went a step further. They said, we would like to know how you can build a spacecraft under these type of commercial contracts. So we would like to have NASA folks have the ability to sit on your review committees or to be consultants into your project. So you don't have to pay them. Perfect. So they are staffing up our technical teams with a few people, about 8 people, which we handpicked, which we had Tom and Scott handpicked. So I think of about perhaps the 5 best spacecraft people in the world. We have 3 of them. Of the top 10 guys in the world, we probably have about 7 of those are now on our team. We have far and away, I think, the best spacecraft engineering team in the world. And we're small. We're sort of 12 people. And we are working with Ball Aerospace, who has assigned the team that built the Kepler Space Telescope over to us. And that's the very best team they have. So we put together this technical team. This is all taking place over the last year. They invested a few $1 million of their own money on improving this design for the Space Telescope. Again, we based it completely upon the spacecraft bus for the Kepler, with the optics from the Spitzer Space Telescope and a brand new detector. And we've been working at it for about a year, to the point now we're coming up on a what's called a systems design review. So we have essentially every system is spec'd out. We have done a complete sort of Monte Carlo analysis of the distribution of asteroids involved with the optics performance, combined with our final orbit, combined with the detector performance that we've got modeled out, combined with the observing cadence that we've got, combined with our data rates back and our ability to track. So we've done the whole full analysis, and we realized we can track essentially all of those asteroids, and we'll do it within about 5.5 years.
With just one satellite?
One satellite, yep.
And
And
what's
those
the
orbits will be, they've given us a firm fixed price proposal, which we gotta be careful how, we can't mention the final price yet because we're in contract negotiations at this point. We've been funding them at some level to.
Who is they?
What's that?
Who is they?
Ball Aerospace. And I can tell you that it is of order a few $100 million, and it is less than the cost of the wing of an army missile.
And launch?
Launch will be on a SpaceX Falcon 9. So
10
they're,
million?
what's that?
10 million?
No, they're much cheaper than the competition, but they're not that cheap. They're going to give us the friends and family discount. They called it, so it's at cost. So again, I can't mention the price, but their commercial price is $60 million. So,
For the big one?
for the big one, yes. The one that flew, for instance, the other couple of weeks back. And
What's the backup strategy?
the backup strategy is you insure the spacecraft, just like the same as you do with other. You build two of a lot of things, you keep them in storage, and you buy insurance. That's the standard for all spacecraft. You know, like when somebody buys a communication spacecraft, you pay another 10%, you buy insurance.
What's the lifespan of the satellite?
It's designed for, operations is 5.5 years, but everything's spec'd for 10 years. And again, once you complete this survey, the survey is valid, meaning the trajectories are still accurate out for about 100 years. So you don't need to repeat this continually. You don't need to, you need to do it completely about once every 100 years.
What about something that comes out of deep space?
Those do happen. Those are comets, the things that are not orbiting tightly around the sun, and they are about a factor of 100 less numerous than asteroids. So there isn't much we can do about those because they come in at nearly a factor of 2 or 3 faster, and you get only months of warning time. So if one of those is going to hit us, it's bad news. But we opted not to hold up what we're doing because we can't solve the remaining 1% of the problem. So we figured we'll attack what we can. And so, on a technical level, things are moving very, very rapidly. We're not quite down to part numbers yet on things, but we're pretty close to it. We have, we know things down, the mass, the power consumption, and so on of things down to probably about 5% right now. It's pretty good. We have funded the initial development of our infrared detector, which is a very, very large format, ultra low noise broadband infrared detector. And we funded 2 subcontractors, both of whom believed they could build it. One of which clearly won the competition. It was sort of a bake-off between the two. And we're now funding them to build build the small unit cells of our detector, which we will chill to our 40-degree Kelvin operating temperature and measure their actual noise. So that's beginning now. Our first group of outside experts is heading to Boulder, Colorado next Wednesday for our first design review of the, we're going to go through each of the individual systems and look at their interfaces with the other systems and our power and our thermal budgets and so on. Rechecking on what the main team has done. And our hope is to sign the big multi-$100 million contract towards the end of this year or the beginning of next year. It's going to take a little time here because, again, the key difference in the way this contract is being done is that you don't, we're not doing what's called a cost-plus contract, which is the way the military always, or NASA develops things. Whatever the contractor, whatever it costs them, you guarantee them a profit on top of it. And you do that when it's something you have no idea how they're going to get there. So if you're landing on, on the moon of Saturn, how are you going to do that 10 years from now? Well, we don't know. So the only way that any company can handle a project like that is to make it cost-plus. And it involves onerous accounting requirements because you have to demonstrate that this is what it really costs us, right? So there's an overhead of a factor of almost 2 just from having to manage things to a government contract like that. In this case, the onus is on us to make sure that what they have proposed building, the blueprints that we have now in hand, are going to do exactly what we want. Then we'll set out a contract with milestones along to build that the spacecraft to that specification, and that'll be what we pay for. So there's a lot more analysis up front, and then sort of rapid construction towards the end, rapid construction and test, which is valid for something like this, which is arguably less complicated than the Mars landing the other night, but much more complicated than anything just orbiting the Earth or something like one of these big spy satellites or something like that. We're sort of halfway in between Sky Crane from Mars and Space Telescope around the Earth. But I've got the team to do it, and we just announced our plans publicly on June 28th, so a month and a few weeks ago. It's been a whirlwind since then. So we're off now raising funds. We're looking for folks who are interested in getting involved. We look at ourselves as being kind of similar to the way large telescopes have been always funded historically. Only in the last so post-World War II have federal funds been used to develop large telescopes. Prior to that, they were almost always privately philanthropically funded. So for instance, Lick Observatory up in the hill here, Palomar Observatory, the Hale Observatory, Yerkes Observatory, all the large telescopes around the world through the 1800s and the early part of the 20th century were publicly financed by philanthropy, or large philanthropists. And so we look at ourselves as being in that line. And if you actually look at the cost of most of those large telescopes, adjusted for inflation until today, we're actually in the range of those things. In fact, the last large publicly financed, or philanthropically privately financed telescope was the Keck Observatory on Mauna Kea in Hawaii, which was about $250 million in 1980-something dollars. So puts us in that range. So we say, hey, we're a big telescope too, except we don't sit on a mountaintop, we orbit the sun. So this is what we're up to, and we have a launch date of 2017 on Falcon 9, and we are going to scan the skies, put together this big catalog of locations, trajectories of all these asteroids, and we're going to put it online. And we're going to see what's in it. If an asteroid is in fact going to hit the Earth, we will have measured its trajectory accurately enough to know where it's going to hit, and its exact orbit, such that you could do something about it.
In fact, isn't there an asteroid that has the potential, with 1 in 500 chance of hitting South America?
Yes, in fact, and it is on February 5th, 2040, that thing might hit the Earth, and which would be in South America if it hits. We know that because essentially we're a little bit uncertainty as its position downtrack. We don't know its timing in 2040 to within a few minutes yet. But the Earth is going right through that, and so depending upon whether it's slightly early or late tells you what. So that's why you actually, if it's going to hit, it actually will hit the Earth somewhere on that line, which runs through South America. And that's nearly 100 megaton impact. So problem is, that asteroid is currently on the other side of the sun, where it will sit for a number of years because it's orbiting in about 1 year period. So, which is why we wanted to be interior like this, so you can pick up those things that are on the other side of the sun. And
In that particular case, will we have enough advance notice then to?
we're just on the edge of it right now.
So how long does it take to actually do the full scan? I mean, how long is it?
5.5 years to complete. We should have 500,000 orbits
So
done.
that's one full
5.5.
orbit of the satellite then?
No, that's about 9 orbits. We're 8-month orbital period. So, and if you're interested, the way you actually track these things is what you do is you look at a region of the sky, then you take you take images of other regions of the sky. You come back to that each region about an hour or so later, and then you look for points that have now moved. Okay, and then you redo that 2 days later. You do that same pattern again. And you look for odd, so now you've got 2 points here and then another 2 points here. And then 26 days later, you do it again. And then you see which lines can run through those moving objects. It's a very difficult computational problem because, with one object, if I see a bright point here and now this bright point here, well, something went from here to here. Now if there's 3 objects, well, did this one go from here to here or this one from here, which one? It's a combinatorially difficult problem. With a million objects, we're going to find 500,000 near-Earth asteroids and several million main belt asteroids. There's a lot of stuff moving out there. It becomes a combinatorially really difficult problem. You're going to have to do that computation on the ground. What we will do on board is onboard data processing to just cut out the regions that move and give potential linkages between them. And the reason we have to do that is because we're so far away from the Earth, the data rates become low that you can't transmit all of your images back to Earth. What we'll do is we'll just show the regions that have moved, or the regions that have changed in intensity. And every couple of weeks, we will then transmit the full image of the whole sky down. And that way you get this, a complete map and then just the points that move,
Okay.
and then every once in a while you do the complete map again. And that's something that there wasn't the capability to do that much onboard processing even 10 years ago. So this kind of mission is something that would never even been possible 10 years ago. For that reason, as well as for the reason that infrared detectors simply weren't available in these wavelength ranges 10 years ago with anywhere as near this kind of noise level. And 10 years ago, there was no such thing as SpaceX. You would have had to use a Delta II launcher or something like that for $200 million just for the launcher. $250 million just for the launcher. So these are a lot of things have changed in the last 10 years that made this mission possible. To the point we're not, and even, truthfully, it was a very, very difficult mission to do even by NASA standards 10 years ago, but now not only is it doable, but it's doable by a private group. So,
Do you have all the funding you need already?
No. This is going to be a 5-year fundraise, very similar to the kind of thing that you do for a museum. In fact, one of our major supporters is the guy who ran the California Academy race. He was the chairman of the California Academy of Sciences for 10 years. Dick Bingham is his name, and he's been helping us model our campaign after what he did for that one. So, and again, that one raised $505 million.
Any thoughts of how to monetize this thing?
We have thoughts, and the reason we are a nonprofit is that any payoff from this is uncertain, and it is not in close. It's clearly not within 5 years. So it makes it sort of a rather poor investment, perfect for philanthropy. But as you may know, I don't know how much you know about the tax laws. Nonprofits, it's perfectly legitimate for them to earn money as long as the money goes back into the program that they're supporting. So for instance, you go to the Sierra website, you can buy a sweatshirt or something like that. You can sell stuff. So we can sell data. We can sell, obviously marketing and things like that. So there's a lot of things we can do that, and we actually have the lift capability of our Falcon 9 launch vehicle is about 400 kilograms larger than the mass of our spacecraft, which means it's nearly 1,000 pounds of extra things we could put on board that can go into orbit around the sun. Not like a low Earth orbit, but a very, very long-term orbit around the sun. Can we monetize that is the question. We think we can, but we are, it's just one of the things that we're keeping in reserve for now. Monetizing isn't so simple because, certain things that we have decide that we're not going to do. You know, like, you could withhold the data and say, you know, we found something that's gonna hit the Earth and pay up, right? But we've chosen instead that
Or
we're
you could be
going
more
to.
specific, we could say,
Well, it's
South
not gonna-
America, we found something that's gonna hit your continent.
Yes,
It's gonna hit Brazil, do you wanna?
Depending on how much you pay you, we'll give you more accuracy about when it's gonna.
Sounds like something
Yeah,
out of,
but
James
that's sort of
Bond.
the Dr. Evil method of doing it. And, you know, we're taking the opposite tack, that we're gonna put everything, online as we get it.
Do you think people will panic?
I don't think so.
Well, they already know about the South America one, and that.
Yeah, I mean, I think people are more rational than you think. I think
Oh, I don't know.
what'll happen, well, I don't think panic is gonna be what's gonna happen. I think, you know, it will wake up government officials, because I think the job of deflecting an asteroid is something that a government is pretty well, governments are well set up to handle, because it becomes a definite threat to a time and a place, and, you know, and now there's, that's something that they can deal with.
So the South America one is a good example. That's one you was actually known about, and, you know, could have come from this data, let's say that's.
Yeah, but it's only 1 in 500 right now.
Okay, there's only 1 in 500 chance it's actually.
That
gonna hit the
particular
Earth.
one will hit the Earth.
Oh, so it's
See.
still slim.
Yes.
So once you scan that guy, then you will know for sure, or what's the?
Well, hopefully, because it's gonna be 5 years till we launch. Um,
But if you launch today,
If we launch today, we would say yes or no.
You'll know for sure.
We would.
What's the margin of error? I mean, you know pretty much a definite yes, or?
Yeah, yeah. I mean, well, you eventually get yourself down there. The longer you track something, the more accurately you get it. In fact, it's not quite so simple, because you can determine the orbital plane very, very accurately. But the timing of the orbit is something that just takes a little bit of time to, because the more tracking you get, the more accurate of a solution you get. And the width of our determination of the plane is only a few kilometers. So we can tell you the width of that line within a couple of kilometers. The length of that line starts out quite long and then will shrink downwards. So when we get to our final accuracy, it'll be, you know, yes or no, and here's the, you know, the 50-mile or so area it's going to hit. It's really quite accurate. It's the beauty of orbital mechanics, right? We know how to solve Newton's equations with corrections for general relativity. That's something that's well understood.
It seems to me it's not too early to ask you to reflect on the source of your success, even though, granted, it's a project still in progress. You know, you have all this personal expertise, you have personal credentials, you have a collection of friends and colleagues who are obviously very valuable. You have sort of title and past affiliation. And you bring all these together to be able to track. It's clear you have a strategy. You find the best people. Who's the best guy?
Yes, that's exactly the strategy.
So, but to get to that, those people could say no to you if they'd never heard of you, if you didn't have the right background and so forth. And this is relevant to us in 100 ways, but one of them is very often big companies get doors open that small companies, you know, startups don't, and so forth.
Mhm.
So in the spirit of, if you had 100% of credit to allocate, you know, which things are most helpful to you in having been as successful as you are so far?
I think the big things have been, number one, that I had spent 10 years looking at this problem, and I do have the background, you know, and I've done significant work in this. And so the the real experts in the field of asteroids, you know, I was part of that, number one. Number two, just because of my NASA background, I knew the very best spacecraft guys. And not super well, but well enough that I could, you know, call them and say, hey, let's just have lunch. And that was partially, and that was through my NASA connections. And from there, and then from the funding aspect, you know, how we've gotten money to get up where we are and to have a hope of doing this was, a lot of that was through Rusty Schweikart, who is sort of my co-conspirator in all this. He's a former Apollo 9 astronaut, first man to fly a lunar module, and has been California Energy Commissioner and, you know, well-known figure for, you know, quite a while. He has a lot of personal connections. In fact, he sat on the board of the California Academy of Sciences with Dick Bingham. So Dick had a lot to do with us sort of getting up and running and getting a strategy of, Dick is an investment banker. He started American Industrial Partners, which is a huge investment bank. And, you know, I would say that those connections have been extraordinarily valuable. A lot of the connections came through having worked at Google. Some of our supporters are former employees of Google or current employees of Google. And so, you know, it's a small world here in Silicon Valley in some sense, but there's a lot of folks here that sort of pride themselves on being able to think big picture and long term. And I think that's part of what the appeal is to folks.
But it sounds like the dark side of this, from the standpoint of, you know, meritocracy, is that it would have been, you know, reading between the lines, many times enormously more difficult for you if you knew everything you knew now about this domain, but you didn't have the past resume bullet points that you could, and the past friendships and so
That
forth. If you just had
could
to
be,
work
but
from
they're,
the things
but
you
remember
know.
they're intertwined.
Yeah.
The reason you get the resume from having the domain knowledge is because you were part of that community for all these years, right? It's
There's
not,
a second order effect.
yeah, but they come together, right? I wouldn't have known, you know, Harold Wrightson or Scott Hubbard, all these guys, if I wasn't sort of deeply involved with that community to begin with, which is how I learned all about the problem and all the nuances and all of what needed to be done. So but you are correct. I mean, we have leveraged our connections as much as, and it's been hugely important. And it's the same thing for starting a company here, right? A lot of times, what separates a company that gets a bunch of funding from one that doesn't? Is it always because that other company is much better? Or is it because they knew a bunch of guys at Kleiner or whoever, right? Clearly true, right? Nothing's a pure meritocracy. It's a very interesting point you bring up, though. But yeah, you know, I think we've managed to get ourselves up and running pretty well.
I'd also like to ask you about the funding aspect of this, because there's what seems to be a material difference between what you're doing and Keck or Lick or all the others you can name. SF MoMA, which is, I could get in my car and drive with my kids to SF MoMA, and as I walk in the building, I see someone's name on it. And there's no question that a lot of people want a legacy, and that's the reason that they visibly give money, not just a tax write-off. Somebody's legacy is going to be floating out in space where no one gets to see it. So how do you reward the people?
Yeah,
who
you can
are
still
donors?
reward people for that. You know, they know they're part of it.
Yeah.
What we're finding is that the ability to walk in and show somebody is less important than you think. They know what they've done. And
Well, you do pretty cool fundraising trips too, as well.
yeah, we've taken some people out to New York Crater, for instance, and we're about to do so again. Taking some people down to JPL to see the Mars landing, for instance. I at first wondered about exactly that. And Dick Bingham kind of convinced me that that wasn't prime among the motivations of most of the donors. They liked having the recognition, but it isn't that they can go visit it.
Not that they can, but you know, if you go to Stanford, see the Gates Computer Science Building, you go
Yes,
to Columbia,
but
you see
there's
the
still
Mud
naming, but remember, there's still
Building.
naming rights,
Yeah.
right? There is a large detector, there is the telescope itself, there is naming possibilities. Also, our data set has naming possibilities. And so
You can name the asteroids.
we actually can. We've been in discussions with the International Astronomical Union. They're the ones who are in charge of the naming of astronomical bodies. And the way it works is that the discoverer gets to submit the name. Still has to be approved. This is the official naming process.
So you would name a particularly threatening asteroid
After
the
your worst
richest
enemy.
person
Yeah.
who did not donate, right?
No, but it's interesting because right now they name about 5 new near-Earth asteroids a month, and they're voted on individually. Well, we're going to discover 20,000 asteroids a month, so their current process does not scale. And It's actually interesting. Our telescope will discover more asteroids than have been discovered throughout history by all other telescopes combined in the first 3 weeks. So the data rates are tremendously high. But so naming, you know, they said, well, we're not opposed to this, but we don't have any way to deal with you suggesting 20,000 names a month. Right? It's just, how do we do that? So currently unresolved, shall we say. You know, we may end up simply doing something like where we maintain the list of, here's the donor's names, here's their asteroid, you want to see where it is, we'll show it to you, online, that sort of stuff. Because they can't vote on this number, you know. But we can put a donor's name on it for sure. So it's one of the things that we're trying to figure out how big of a deal we want to make that. So there's a lot of things that.
I'd give you $100 to have my name on an asteroid.
Would you?
Yeah.
What, 1,000?
I have a small asteroid.
Okay.
I don't want to put my name on something that's going to wipe the planet out.
Peaceful.
Other than us going to the website and donating, because you accept donations on the site, are there any other asks you have of us?
Well, yeah, it's to spread the word, you know, and we are looking for ideas of ways to reach as many people as possible. You know, there's sort of two aspects of this. You know, every large fundraising campaign always has, truthfully, it's a couple of 2, 3, 4, 5 large donors that will account for 50%. We've looked at hundreds of these campaigns, and they all look like that. Then the remaining sort of like, there'll be a number of folks, you know, the stretching out the rest of it, you know, all the way down from, you know, by, you know, tens of thousands down to the sort of like $100 donations, many of them, which will all add up to maybe 30%, something like that. And then typically you get 10, 20% from foundations or whatever, you know, either marketing or who knows what. And, but one of the things that the very biggest donors look at is how many are there of the small donations? How many, because it gets back to the recognition thing. They want to know that people care what they're doing. That's more important, as it turns out, than my name on it and I'd bring my grandkids to see it. And so there's where it's a second order leverage point, but it's important. You know, when we went public, we got a huge splash. I don't know, something like 400 or so news articles about it, which was pretty good. But we've got to sustain that, you know, and we need to keep folks interested in this and to sort of hear the message that, but we want to make it sort of a message that's not negative in the sense that, oh, you know, where it's going to end, but more positive, which is that if you think about it, this is something really, really awe-inspiring in some sense, right? We're talking about finding and tracking objects, you know, in our solar system and potentially changing the orbits of them to prevent the third planet of this particular star ever being hit by a large asteroid again. Right? That's kind of interesting, right? I mean, this planet has for 4.5 billion years been struck by large asteroids. You know, every million years or so, there's something large enough that would wipe out, you know, any advanced civilization. Every 40 or 50 million years, there's something large enough to wipe out 90% of all species. It's just happened repeatedly on this planet. That should change right now.
Are you going to track asteroids that might hit other planets in our solar system?
Yeah, you'll get that for free. I mean, because you'll know, you can, once you know the orbits of
Because
them.
if something huge hits one of them and it kicks out a load of bits.
It really won't kick that much out, but it will be quite a spectacle. In fact, that's how we found the one that hit Jupiter.
Mm-hmm.
Carolyn Shoemaker, Shoemaker of the EV9 is the one that hit Jupiter, and it was quite a cosmic show.
But that was that impact was spotted by an amateur, wasn't it?
No.
Wasn't it? I
No,
thought there was
no.
one-
Carolyn Shoemaker has discovered more comets than any other human alive, so she's pretty good at it.
Wasn't there one that
And
hit-
well, David Levy is a could have been called. He was somewhere in between a professional and an amateur, in that he was sort of like the best known amateur one, but the level of his equipment was pretty much professional. And so they're the co-discoverers of that one. The first realization that it was going to hit the Earth was done by some scientists at NASA who looked forward and go, wait a second, this thing's actually going to run into Jupiter. And that's when the thing spooled up.
Mhm.
In fact, Carolyn is one of our advisors, which is nice. She's a sprightly old lady in her mid-80s. Still has a lot of energy. She's a great lady.
So what's the cost of deflecting an asteroid once you, if you have 40 years, then it's a warning?
Typical space mission of this size is probably 500 million. So
500 million?
Yeah, typical space mission of this size. I assume, though, that if it really comes down to something's going to hit the Earth, you will build multiple copies. You know, you're probably looking to spend it a couple of billion. So, yeah, you know, the equivalent of what the agriculture department spends in 2 days. Right?
Or one bomber, ironically.
Yeah, there you go. The Department of Agriculture spends, what, about $180 billion a year, something like that? So 2 days worth of Department of Agriculture's.
So what's it like working with SpaceX?
They've been great so far. We've only really talked to Elon a bunch of times, but mostly it's about the the technical things. What is the vibration levels? What is the the acceleration levels? And what kind of accuracy are we going to get off of our initial Earth departure stage for things like that. So they have come a long ways in maturity since even a few years ago. So there's evidence by the fact that they just sent something to the space station a couple of weeks ago, right?
Mm-hmm.
They're doing great. Yeah, I think they had an attitude a few years ago that, oh man, all those guys at NASA don't know anything, right? And after they blew up a whole bunch of things in a row, they realized, well, maybe they do. But what they have done is really, really streamline or optimize the process for cost, which was never done. It was never even a design goal early on, right? For any of the NASA things, it was simply getting it to work, and they've been doing great, I think. Great work.
So he didn't laugh when you phoned him up? He
No.
said you wanted to deflect asteroids and find them and things?
No, he's well aware of this. I mean, anyone in the space community knows these odds, and there's no dispute about the odds. We know how you can count craters on the moon to find the rate of large asteroid impacts. You can count bolide impacts. Those are the sort of the things that show up in the upper atmosphere because we have spy satellites looking down, looking for nuclear tests and rocket launches. It shows up in the infrared. There's a lot of heat, and all that data has been declassified from both the old Soviet and the Russian, and all the U.S. satellites have been declassified. And we know the impact rates. So that's at the low end of the scale. It's a pretty nice power law distribution, which is what you get when you have the populations produced by basically collisions. It's a self-replicating. Small ones collide more often than large ones because there are less of them, and you end up with a power law distribution. So we know the distribution very, very well within a 20% in any given size or an inch or so.
When was the last time something big hit the moon?
They have seen flashes before, sort of small size, quarter, 20, 30, 50 centimeter type things, which people have caught live.
Mm-hmm.
There have been ones where somebody noticed, hey, that crater looks different, and that's happened a number of times. So it happens pretty frequently. Nothing is sort of like shatteringly large, kind of thing.
So the moon isn't going to land on us anytime soon then?
No, you're not going to move the moon. But in terms of, if it was an ask, it would be to spread the word, tell people about it. Or if you have ideas, what I'm looking for is ideas. How do we reach 1 million people?
Kickstarter.
Well, we don't want to go down that, people have suggested that to us. We just have to be real careful on that. Kickstarter is for very small projects in general. It's been a couple of larger ones, but in general, it's guys, making T-shirts and things like that. And you have to be careful of associating yourself on some level with guys doing T-shirts, right? Because, again, if half your money's coming from the very largest donors, they want to be seen as doing something that's state of the art, And you know, this is something that Dick Bingham really cautioned us on up front. He said, you know, the folks who are really going to make this happen want to know that these are the best people in the world working on it, and this is a project that is being done to the very best, you know, held to the highest standards as possible. And so don't, you know, just be careful who you associate yourself with. In the same way that you got to be careful who you accept money from, because it can affect who others later might say, well, I don't want to associate with that person. So just something, which is very similar to investing, right? When people are searching, you know, are raising money for, you know, for investment reasons, for companies, right? You want to show them that you know what you're doing, that you are very, very good. It's about the people, right? They're investing in the people that are going to get this done, and that they believe that the end product is something they want to see happen. And then, you know, typically, you know, most investments, as things grow, are done in, you know, it's teams of investors. You know, it's consortia, right? You know, it's never one VC funds at all, right? They go in with others, right? And putting together that team is also critical. Right? You got to make sure that these are, when one large person has invested money, that there are others who want to be with them, and not other ones who go, oh, I don't want to associate with that guy. That may in the end hurt your, taking money from somebody like that can hurt your chances of raising the rest of your funds. So, in fact, you know, I think the psychology is actually quite similar. In fact, the people are quite similar. It often, you know, the people who invest in companies are often the people who also donate money to philanthropy.
Do you think for a project to deflect an asteroid, do you think there's a test necessary?
We do, I think so, but we had to, and that was originally the focus of what we were doing, was to try and get a test mission up, because you know, my feeling is that you don't want your first research test project to be the one that actually counts, right? But we pretty soon came to the realization that, you know, again, if you don't find them, all the tests, you know, the test doesn't mean anything.
Maybe that's your second project?
Maybe that'll be a second project. We got first things first though, so we're going to really focus on doing this. We've come a long ways technically, and we have an incredible team. We have some of the money raised, not all. But it, you know, we've only been raising money really for a few months.
Who else is on your advisory board?
Advisory board has Lord Martin Rees. He is the Astronomer Royal. We have Freeman Dyson from the Institute for Advanced Study. We have some folks who are more from the business world. Phil Later, he was a former ambassador to UK, and he's the chairman of the largest advertising agency in the world, WPP. We have Jeff Baer, you know, from formerly of Sun and then US Venture Partners. We have Dick Bingham from California Academy of Sciences and head of U.S. Industrial Partners, that huge investment bank. We have some folks who are Erwin Shapiro from the Hubbard Center for Astrophysics. He's the head of the National Academy's group that looks at solar system astronomy. So we have a mixture of folks who are sort of more policy, some are more technical, some are more scientific. Pretty broad, diverse group. It's all on our website. So.
Have
Nice
you considered
folks.
the celebrity round?
In what sense? You mean the celebrity
Money raising.
You mean going to LA and hoping to get raised money? We have some, a couple of our advisors are sort of part of that community and or know a lot of folks there. We haven't had anyone who's been a large, you know, a Hollywood type donate anything significant yet. There's a couple that we've talked to, but you know, the very large donors, they take a little while to make up their minds on anything. You know, they have their sort of like small check they can write without thinking about it, and the larger things is something they really need to spend some. You know, this is a many-year commitment type thing. So no.
Who would you like if you could pick a celebrity? Who would you have?
Bruce Willis, obviously.
What's that?
Bruce Willis.
Yeah, actually, one of our advisors is actually friends with him. The person that we've been talking to, you know, for as much for strategic reasons as anything else, is George Lucas.
That would be very cool.
He's friends with Rusty.
Mhm.
It gets back to this connection thing with the Apollo astronauts, they're friends with everybody, so. But as much from his ability to perhaps help us tell our story, which we think is important.
You
Could
can
make
go
you
to
a
each of
real
the
good
political
leader.
parties' PACs and have the Republicans buy the biggest, most threatening one and call it Obama 2012 and then the vice president.
That's a great
You get a
idea.
lot of money.
Yeah, I mean, you know, look at the amounts of money that we're trying to raise are, you know, on an annual basis, you know, dwarfed by the political campaigns. And, you know, our hope is that there are folks who think that, oh, well, maybe, you know, a small fraction of what I donate politically might be good for something like this.
I mean, you gotta assume that you're not gonna have trouble raising the money you need, considering how much you're looking at.
Yeah, we think we'll be able to do it, kind of.
And considering what it brings.
Yeah, I mean, Dick Bingham has been great at helping coach us through this. He goes, yeah, it looks very, very daunting. He goes, and whatever you think, however hard you think it will be twice as hard, but you'll get there. And he goes, and the people who you are sure are gonna donate money when you think about it up front may or may not be the ones that donate money. People will come out of the blue who you'd never heard of or thought of as donating money and will donate a lot. He goes, that's the way these things always work.
William Shatner, that's who you should go after.
Captain Kirk.
That would be really good. I'd pay to see that.
You know, we could. We'd actually talked about inviting Bruce Willis to do one of the voiceovers for one of our videos, which we might do, just for
Sure.
fun.
You should, because I think.
Because
yeah.
nearly every reporter who writes about this thinks they're original and witty when they mention Bruce Willis. They think they're the only reporter, but essentially 98% of all newspaper articles mention Bruce Willis. Because every reporter thinks, I'm so witty. And, you know, and they put in the Bruce Willis reference. And
So you were mentioning about how you get publicity, obviously, publicity over a period of time.
Yeah.
Which is harder than publicity at one time.
Yes, much harder.
The most obvious would that your group gets a mention in a movie. So a movie that involves space or
Yeah, one of the things we're
something.
working on right now is getting on this TV show Big Bang.
Oh, yeah.
Oh, that's great.
One of the,
Sheldon Cooper.
he always wears a different T-shirt.
Yes, he
And
does.
one of the writers is good friends with one of our donors.
You might be able to get them to wear a B612 shirt. And
Yeah,
explain
we're
what
trying
it
to
is.
get them to even do an episode.
That's cool. Yeah.
That would be really good.
Yeah,
Or just
we'll
rename
see.
yourselves Apple and you get all the free.
I think others have tried that. But,
That would be really good. I love that show.
yeah, so I think we have things, from a technical standpoint, we have, you know, I think our team is, the majority of our team is in place. And it's, where we are, where we have a lot of work to do is on outreach, is on, you know, social media, it's websites, it's small events with larger donors, it's things like that. And those are gonna require volunteers and things, just in the same way as all these other campaigns do.
Do you have any concerns raising money from outside of US?
Oh, no, in fact, we believe that sort of it's inherently an international problem.
Right.
And absolutely, yes. So we have spoken to some very large donors from a number of different countries.
So you talk about a small world, so tomorrow I happen to be meeting the head of the space program for Brazil.
Oh, really?
Yeah,
Okay.
so they're motivated.
How did that come on?
It's through a friend of my wife's from growing up.
Oh, really? Okay. Yeah, they have one astronaut, Marcos Pontes. He's a really nice guy. I think he's moved back there. He flew last 2 years ago, and then I think he's moved back to Brazil. But I'm sure they'll know Marcos because there's only one astronaut. So.
I have to ask you, was this your screensaver shot, was that from your, a photograph you took from the space station?
Oh, yeah.
Oh.
Yeah.
Well, you have some of your pictures up on the web, don't you?
Yeah, I got a bunch of them.
Mhm.
Took a hell of a lot of pictures when I was up there.
And then you were 6 months continuously on the station?
Mhm.
And then when you returned, did you have any adverse effects?
The physical recovery is quick, a couple of weeks maybe. The recovery to getting your life back in order takes a long, long time. I left town on very short notice, like 48 hours, and then to spend sort of 2.5 months training in Russia, and then 6 months in orbit, and then another month back in Russia before I flew back. So it's been 9 months since I was back at home. And I wasn't married yet at the time. And so my house had basically fallen apart. Air conditioning was busted, my bills were bouncing. What I had done was I had put all my bills on a credit card. And then I put a bunch of money in my, auto-debited it to, auto-paid it off my credit card. But what happened was, somewhere along the line, I didn't even really think this through well, is that they send you a new credit card that has to be activated. Right? So all my bills started bouncing. So I get back, my phone's disconnected, it was a mess. My car's out of registration, doesn't start. I got a ticket the day after I got back to Houston because my safety inspection was out.
Isn't government's job to take care of all these things when they send you for an important project like that?
I'm imagining the
Yeah,
phone
they
calls
did,
and the
yeah.
talking to the cop. I was out of the country.
It was just easier,
I was
because
off-world.
it literally took me about 6 months to sort of answer my mail, catch up to, email had just gone bananas.
You don't get email on the station?
No, we do, but it was a different account, and I just said, I put the, I'm not replying, I put the bouncer.
But do
thing
you have
in
an
there,
out of planet?
I don't even remember what I wrote on that, it was one of those things, it's just like, it was a low priority, just get my stuff together, pack my stuff, and get on an airplane and go.
You were there, you say, with one Russian guy
Yeah.
for months.
Who's back in space again, he's as of a couple of weeks ago, he's back.
I'm
in
curious
space.
whether you were, speaking Russian to him all the time and that.
Halfway.
So that's kind of an
He's-
adaptation too.
Well, he speaks English and I speak Russian, so
Yeah.
we.
And then, did you have something like ham radio on, while you were up there, to talk to other people, or was he the only person besides, say, mission control?
Well, you talk to Mission Control, that's a fair number of people within Mission Control.
But
We
some
we had
people-
ham radio up there, I talked to a couple of other people, but not much, but,
Yeah.
you,
Mainly it's that guy.
yeah.
Are you still friends?
Yeah, yeah. Talk to him every once in a while, not lately, because he's back in space again right now, but, yeah, I got an email from him a few months back before he left.
Thank you so much.
Well, a little something different, I guess,
Yeah,
maybe
absolutely.
different than your
Very
usual.
interesting. Very
Go to the website, check it out,
Send money.
Spread the word.
Sure, send money if you want, that would be great, obviously, but I think bigger thing is spreading the word. Tell people that there's something interesting going on here, and it is possible to actually help make it happen in some sense, right? So I don't know how much we're gonna raise by the smallish donations, although they have a proportionally larger effect early on, right? Which is the same for a company,
Means we're
right?
higher up the naming list for the asteroids.
Yeah, once we figure out our policy on all that, that's gonna take a little while, I think.
eBay. That's auction them off.
No, don't auction them off.
He's
Give them
put
to
some,
early donors.
he's put some hope, maybe global warming will be solved somehow.
Yeah, well, global warming, I think, is is going to be a 1,000 times more expensive to figure out how to
Sure.
do that, because you have to change the economy of the world
Yeah.
and the attitudes of a few billion people.
Yeah.
Here, you just need to get like 1 million donors and do something that's maybe a few $100 million instead of $1 trillion, or $10 trillion. Who knows what takes to change the economy? But so we're doing something way easier.
No, that's-
But what's nice is at least we have a solution.
And it's long-term and people invest in it, so that's encouraging.
Yeah,
you know,
and
because very
it's
few
also
goals
well
are-
defined. That's the other thing. You know, one of our major donors has told us, because the thing he likes about what we're doing, the what reason he thinks we'll be successful is that we're so well defined in what we want to do.
Sure.
You know, there isn't this like, what are we really about? You know, kind of discussions. You know, little, you know, course correction type thing. You don't see it, you know, because what we're trying to do is so well defined. I think that'll be very helpful. That's a good lesson for a company too. If you can do it, not all companies have that luxury.
Yeah, but also you need the publicist's tagline in the style of Steve Jobs, it's like, you know, first Ed saw the planet, now he's saving it. Right? I mean, that's, you
Yeah,
know, simple,
we do
you
need
know.
some sort of tagline. We haven't, you know, we haven't spent as much effort on public relations because we didn't even go public until 1 month ago. So, but we do have a person who's doing our PR. She used to do the PR for the X Prize Foundation. So, and before that, she was head of PR for Northrop Grumman. So she's very, very good. But she runs her own little agency right now, and we're a small operation.
That's good.
We'll take a 10-minute break.
Thanks again.
Thank you.
Something different.